We're doing a new concept that is probably one of the more challenging things you will do in Algebra 1B, okay? Mostly because I think people don't think through the process. Like, what is this that we're actually doing? So I'm going to try to explain to you what we are doing so that the how we are doing it comes easy, okay? So here it is. We're doing something called rationalizing a denominator. In other words, the rule is you are not allowed to leave a radical, this symbol, in the denominator at all, ever. It is never allowed in math, okay? As a simplified answer. It will show up from time to time, but you need to get it out of there in your simplest form, okay? The way we do that is we rationalize it by multiplying by something that's going to essentially rearrange our answer, not change the value of it. Okay, so we're not trying to say, oh, multiply by 2, because that's going to change the value of it. If I have the number 4 and I multiply by 2, it is now an 8, right? But what if I have the number 4 and I multiply by 2 over 2? What's 2 over 2? It's 1. Does that change the value of my 4? No, it's still 4 when we're done, okay? So here's essentially what you're doing. If you can remember every single time to multiply by 1, you're going to be golden, okay? The issue is it's not going to look like the number 1. It's going to be something over itself every time, okay? Here it is. So what it says here is to rationalize the denominator, you're going to multiply the numerator and denominator by the radical in the denominator. So you're going to look at your denominator and you're going to go, oh, I'm going to multiply by that thing over itself because that thing over itself equals 1. But remember, a radical times itself ditches the radical. Like if I say the square root of 2 times the square root of 2, that equals what? 2. The square root of 4, which is 2. If I said the square root of 8 and I multiplied by the square root of 8, it equals what? 8. Okay? So that's why we want to multiply by the radical in the denominator, because then it's going to get the radical out of the denominator. Okay? Are you ready to try this? Here's what we do. Currently, I have 4 over the square root of 7. Is that allowed? Why not? Why? What's not allowed? No radical in the denominator. Okay, so this is not a good answer. Okay? It has a value. It's just not written well. We're not going to change the value. We're going to change how it's written. So we're going to multiply by the number 1. So this needs to equal 1. Your denominator you currently have is a rad 7. So the way we're going to multiply it is we're going to take the square root of 7 over the square root of 7. Do you agree that that equals 1? Yeah, so I'm just multiplying this thing by 1, which is going to rearrange how it's written. How do you multiply fractions? Do you need a common denominator to multiply fractions? No. So all we have to do is go straight across now. What's 4 times the square root of 7? Can I multiply those two numbers? No, one's a radical, one is not. So you're going to write that as 4 rad 7. What is the square root of 7 times the square root of 7? 7. It's the square root of 49, which is 7. Is this an acceptable answer? Yeah, you can have a radical in your numerator. You just cannot have a radical in your denominator. So that's your answer, and we're done. Now, if we could have simplified that, we would, but 4 and 7 are not divisible by any same number. So it's done, and we are good to go on that one. Questions on that? Okay, jump over to 14. Is this an acceptable way to leave an answer? No, because of what? The radical in your denominator. Okay, so if I can't have a radical in the denominator and I want to get it out of there, I'm going to multiply by what?
2.
Not 2. Multiply by 1 in the form of over rad 2. Rad 2, so you take the denominator over itself. Rad 2 and rad 2. What's our next move?
Multiply the top.
Multiply your numerators. Okay, are you allowed to multiply the 5 and the 2 right now?
Yeah.
Because they're both radicals. So this is going to be the square root of 10. Are you allowed to multiply these right now?
Yes.
What is rad 2 times rad 2?
Just 2.
It's 2, okay? Any radical times itself is the radicand. Are you allowed to divide the 10 in 2 right now? No, one's a radical, one's not. Can that 10 break down to anything simpler? No perfect square that 10's divisible by, so you're done. Okay, go over to 15. This one is written a little different. Do you see the difference here? The radical's around the whole thing versus the radical is like here. There was a rad on top and a rad on bottom. I would recommend that you write that separate. If you don't need to, that's fine. I think you see it better when you just break it down. So the square root of 81 over the square root of 2. Now I'm hoping that when you look at this problem, something jumps out at you that's different than the other two we did. Does anyone see it? 9. The square root of 81 is 9. Okay, so if you can take a perfect square, take a perfect square. So we could technically simplify this to 9 over rad 2. If you didn't do that right now, you'd be okay because you would just simplify it in the end. But I think it simplifies your life a little bit if you do it right away. Okay, so you're here. What's your next move?
You multiply it by 2, but not 2, 1.
By 1 in the form of what? Like, what are we going to put over here? Rad 2 over rad 2. Okay, we're multiplying by 1, but just making it look different. So rad 2 over rad 2. What's your next move?
You multiply the top, it's 9 rad 2, and then the bottom is just 2.
Right, multiply across here, you get 9 rad 2. Multiply across here, rad 2 times rad 2. Now, I get in the habit of saying a radical times itself is always the radicand, right? Rad 2 times rad 2 is 2. And if you want to get in that habit, great. If you don't love that, rad 2 times rad 2 is rad 4, and rad 4 is 2. So you don't have to take the shortcut that I take. If you want to think of it this way and then turn it into the 2, that's fine. Can we simplify that 9 and 2? Are those divisible? They're not. So you're just done. This is your answer. Be careful not to simplify this one either, right? One's a radical, one's not, so you can't divide those.
Wait, how did you get the 9 back 2 and not just 9 over 2?
So did you get this part of it where we multiply by rad 2 over rad 2? Now we just multiply straight across. So 9 times rad 2, you can't turn into 18 because one is a radical and one's not, right? So you got to keep those separate when one's a radical and one is not a radical. Okay. I feel like every one of these has some different element to it. 16 is a little bit different, but I kind of want you to try it on your own. Use what we know from yesterday, Friday. Use what you've seen from right now, because if you simplify things first, they're usually easier problems. Like this one, it's tempting to go, oh, multiply by rad 18 over rad 18, but you get huge numbers, and then you have to do all this simplifying later. There should be something that simplifies first here, and then you can rationalize. Okay, so see if you can figure that one out. I did it, but that still worked. So the way that I set it up and the way that I saw some of you set it up is you could right now call 6 over 18 what over what? 1/3. Okay, here's where I think a lot of people mix it up a little bit. This is all a radical right now, right? So if I divide by 6 on both parts, it's still a radical. Oops, divide by 6, not right, 6. So this is 1. And this is 3, because I just divided both parts by 6. What's the square root of 1? It's 1. So you can make that 1 over the square root of 3. Okay, then your next move would be to rationalize. What are we going to multiply by?
The square root of 3.
Over?
3. The square root of 3.
Right. So on top, you have the square root of 3. On bottom,
3.
you have 3. Okay, so that's one way to do it. The other way that I saw a couple of you do it, which is just as lovely, is instead of dividing this right away, breaking this down into simplest radical form. So this would be 9 and 2. So it would be the square root of 6 over 3 root 2. If you do it this way, what are you going to multiply top and bottom by? Root 2 over root 2, right? Keep the radical with it. So root 2 over root 2, which gives you a rad 6 times rad 2 is rad 12. And then on bottom, you have 3 times 2, which is 6. That then gets broken down. So you break this into the square root of 4 and the square root of 3, which is 2 rad 3 over 6. And look what happens. 2 over 6 is 1 over 3. So I would say this way that some of you did is a little bit more work, but you still get to the same point. So if that's the way your brain sees it, run with it. That's totally fine. Questions on that? Okay. One more? You got one more in you? Let's see. Let's just keep going. Let's do 17. No, I lied. Let's do 21. 22? Sure, we can do 22. 22 has an option for you here. Does anyone see something you could do right now to simplify? You could divide the 3 and the 6, right? The two radicals. So you could call this 2 over 3 still. But these are both divisible by 3. So if you divide by 3, it's the square root of 1 and the square root of 2. What can you do next?
Can't you multiply the 2 and the 3? And then plus 2?
Can't you just multiply by 2?
Over rad 2, right? What does this equal? 1. So really your numerator right now is just 2. Right? Because the square root of 1 is just 1. So that doesn't change anything. Now we have to rationalize. Now we have to get that radical out of there. So we're going to multiply by rad 2 over rad 2. What's your numerator?
6.
Numerator, the top one.
Oh.
Just 2 or rad 2?
2 rad 2. Yep. 2 times the square root of 2. We can't multiply those because one's a radical and one is not. Your denominator is the 6 that Isaiah was saying. Rad 2 times rad 2 is 2. So you're going 3 times 2, which is 6. Are we done?
Yeah. No, you can multiply 2 and 6, right?
Not multiply them. It's a fraction. Divide. Treat it like a fraction that you can reduce, right? So 2 over 6 would reduce to 1 over 3. Divide everything by 2. So you end up with the square root of 2 over 3. Okay. Here's the deal. If you didn't reduce on this one, you can still get there. It just takes more work. So like, I lied. I'm going to give you one more. You don't even have to write this down with me. I just want you to see the difference between reducing first and not reducing first, okay? So you can just watch and see if this makes sense to you. I could right now, if I didn't reduce, I could just multiply by the square root of 12 over the square root of 12, okay? If I do that, I get 4 times the square root of 60 over 12, okay? But that means now this has to get broken down and this has to get reduced. If I simplify it first, I get the square root of 4 and the square root of 3, which is 4 rad 5 over 2 rad 3. And now it's 4 over 2, so there's no number on bottom anymore. It's a 1. So now it's 2 rad 5 over rad 3. And now I don't have to multiply by such a big number. So I would get 2 rad 15 over 3. That's your final answer, which is what you would have gotten to here. But you just get there with smaller numbers if you simplify things first, okay? But I promise you would still get there. This would be the square root of 4 and the square root of 15. So that would be 4 times 2 times the square root of 15 over 12, or 8 root 15 over 12. Divide both those by 4, and you get 2 rad 15 over 3. So either way I got there, it's more just a matter of how did your brain see it? What does your brain prefer? Do you want to simplify first, or do you not care if you have bigger numbers to work with and then you simplify in the end? Okay? They both work. It's kind of up to you. Questions on any of that? Okay. Historically speaking, this is a tougher section for a lot of people just because it's hard to wrap your brain around it. So what I need you to remember is you are just multiplying by 1 most of the time. And that 1 is usually going to be a radical, is always going to be a radical over itself. Rad 6 over rad 6. Rad 11 over rad 11. Rad 2 over rad 2. Every single time multiply by 1. Okay? All right.